All right, in my last video, we introduced the binomial probability distribution. We defined the terms, and we looked at the formula. This video is going to focus on using the formula to actually get the answer, and we will also be talking about determining the mean and the standard deviation. So this formula looks a little intimidating, but fortunately we have a calculator, and in the calculator we're going to use the Binomial PDF distribution, and we're going to insert n, p, x. Some books actually, instead of using x here, they actually use r for success. So you can say you're entering in NPR. We're going with x here. You're going to n, p, x. So let's look at how to do that. I pulled up my calculator here. Going to turn it on. And we're going to need to pull up the binomial distribution, and the distribution would be under second vars. So second distr, and distr is short for distribution. So we're going to scroll down here, and then 0 and a are the two that are important for this topic. Here we have the binomial, and that's what we want. So we're going to select that. Then we need our n. So in our last example, we talked about rolling a 6-sided die, rolling a 5. You'd have a 1 in 6 chance of rolling a 5 in 6 chance of not rolling a 5. Let's say you roll that die 7 times, and you get exactly 2 successes. You roll a 5 twice. So what you need to enter in, binomial PDF, 7, 1/6, probability of a success in a single event. So you have 7 events. The likelihood of having a success each time is 1 in 6, and then the number of successes, 2. So you're rolling and getting 2 5s. Maybe you get a 5 and a 5, and then you have 5 straight rolls that are different things. Maybe you get a 5 on the second and fourth roll. That part doesn't matter. What matters is you're getting exactly 2 5s. And the calculator will calculate it for you. So that's a little less than 25%. So 23.44% of the time you roll a die 7 times, you would expect to get exactly 2 5s. So that's how you use the calculator to calculate the binomial PDF. Already used this. I use the calculator to calculate a binomial distribution probability. But we're going to look at a slightly different problem now. Let's go back to this example. And now let's say instead of getting a 5 2 times, let's say I get a 5 2 times or less. All right, slightly different language here. Instead of getting a 5 exactly 2 times, getting a 5 2 times or less. So I'm rolling the die 7 times. I'm either not getting any 5s, I'm getting just 1 5, or I'm getting 2 5s. So everything would stay the same. What we're looking for here is the probability of x being less than or equal to, so less than, and then I gotta stick in the equal to line in a second, 2. So let's stick in that equal to line here. All right, probability of x being less than or equal to 2. So that would be the same as the probability of having exactly 2, which is what we just calculated on the calculator, plus the probability of exactly 1, plus the probability of exactly 0. Now, I can do that in my calculator. I could add all 3 of these probabilities together. I could do binom 7, 1, 6, 2, binom 7, 1, 6, 1, binom 7, 1, 6, 0. But that's a little cumbersome. So there's a quicker way to go about doing that in the calculator, and that is with the binom CDF. So let's go ahead and do that now. We're going to go back to binom CDF. So the C stands for cumulative. So this would be our example over here. 7, 1, 6, 2. So the likelihood of rolling exactly 2 or exactly 1 or exactly 0, the probability of rolling 2 or less would be about 90%. Most of the time you roll the dice 7 times, you're going to get 5 2 or less times. So